When a new flagship AI model drops, the headline is usually about how smart it is on a single prompt. But for Anthropic's new Claude Opus 4.7, the real question is whether it can handle messy, multi-step tasks without failing or requiring a human to step in. This diagnostic dashboard frames Opus 4.7 as an architectural blueprint for migrating to autonomous AI workers. It's built specifically to address how a model performs under the pressure of operational reality. Looking at the baseline specs, Opus 4.7 replaces 4.6 as the top-tier reasoning model. It standardizes a 1 million token context window, holding entire technical libraries in memory. The pricing table shows token costs remain unchanged. It's positioned as the new standard, not a premium tier. The past was defined by single-turn chat, a prompt, an answer, and the interaction ends. This new architecture prioritizes persistence. It is designed to cycle through tool use, file memory, and self-correction, pushing through failures until the task is complete. Anthropic is targeting a specific outcome, a dependable operator that can handle a project's lifecycle instead of an assistant that simply answers questions. That transition to autonomous work is driven by specific upgrades to the model's reasoning engine and its ability to perceive visual data. These benchmarks show the measurable gains. In agentic coding, Opus 4.7 scores 87.6%, and it maintains a high read in graduate-level reasoning. These aren't just chat improvements. They are metrics for technical problem-solving. These gains extend into enterprise knowledge work. This chart shows Opus 4.7 leading in tasks like redlining documents, editing presentations, and analyzing complex charts, where formatting and visual accuracy are critical. The visual sensing has seen a major jump. This resolution scale shows the increase from 1.15 megapixels to 3.75 megapixels. This enables one-to-one pixel mapping. When interacting with dense dashboards or UI screenshots, it can identify coordinates exactly, a requirement for reliable computer use workflows. However, high-resolution processing creates an operational trade-off. Feeding full-resolution images into the system uses up to 3 times more tokens, significantly accelerating your budget burn. This visual acuity and reasoning allows the model to see a digital environment and execute work within it, rather than just talking about it. Because autonomous agents work independently, they need strict controls to prevent them from endlessly overthinking simple logic or getting stuck in expensive loops. Developers now have effort levels to govern this. This graph identifies the X-high zone, a setting designed to maximize thoroughness for coding and agentic loops without hitting the diminishing returns of the absolute maximum setting. There's also a new task budget feature. It works like a countdown clock, allowing the model to see its remaining token allowance so it can gracefully finish its work before the budget expires. The model's default behavior is now more literal. As this slider shows, it no longer infers unstated intent. Tool use is also more conservative by default, leaning on internal reasoning unless developers explicitly demand more aggressive tool deployment. These controls function as safety valves, making it possible to deploy long-horizon agents while keeping the economics of the task under control. The catch is that because Opus 4.7 follows a different logic than previous versions, it is not a dropping replacement for existing code bases. This API diagnostic identifies the breaking changes. Old sampling parameters and extended thinking budgets will now return errors. Developers must transition to the new adaptive thinking implementation. There's also a secondary financial cost hidden in how the model processes text. Opus 4.7 uses a brand new tokenizer. This tokenizer is less dense, meaning for the exact same text, it may use up to 35% more tokens. Even with unchanged pricing, your actual task cost may increase, requiring immediate budget recalibration. Weighing the measurable gains in autonomy and vision against the friction of API updates and token expansion provides a clear diagnostic. Opus 4.7 offers significant reliability for complex work, but it demands active management from the developers deploying it. Ultimately, Opus 4.7 proves the AI industry is shifting toward real digital operators. That achieving that dependability requires a model that is steered by strict controls, not just a simple model swap.